Hello everyone. After completion of number system, the next chapter is LCM and HCF. This chapter is also important for basics. If we are good at number system, LCM, HCF, ratio, proportions and percentages, these four chapters are for basics to solve remaining any chapters. So that's why this is also one of the very important chapter for basics actually. So we all know about what is LCM and what is HCF. Again, I recall here. LCM is nothing but least common multiple. HCF is nothing but highest common factor. Highest common factor. In school days, we learn it as GCD also, nothing but greatest common divisor. Both are same, HCF or GCD, anything is fine. So here least common multiple, in the name itself multiples. So suppose if I take 3 multiples means 3, then 3 multiples 6, 9, 12, 18, 21, 24, 27, 30, like these are the multiples. Similarly, suppose 5 multiples are 5, 10, 15, 20, 25, 30, 35, 40, these are the 5 multiples. 6 multiples nothing but 6, 12, 18, 24, 30, 36, 42, these are the multiples. Suppose question is, what is the least common multiple for 3, 5 and 6? Suppose, just observe all these multiples. So, what is the least common multiple? Common multiple in all these 3 multiples. So, observe in all this, which is the least common means, in this also 30, here also 30, here also 30. So, least common multiple is LCM of 3, 5 and 6 is how much means? 30. Like that we are going to say. Right, always it is time waste to write all multiples and analyze which one is the least. Not only 30, the 30 is the least multiple, but common multiples of 3, 5 and 6 means 30 multiples. 30, 60, 90, these are the cases. Suppose if 30 is not there in the options, then we go for that 60, 90 or any 30 multiple is there. Only none of the above is not there in the option. At that time, for some problem solving purpose, so we take any one of the LCM and substitute whatever the requirements according to that problem, right? So LCM is nothing but this is the, like this actually least common multiple. Always it is not possible to write all multiples and find a list. So for that we will solve, we will find that LCM in different ways, prime factorization ways and short division based. So we look into that and similarly. Suppose HCF or greatest common divisor, GCD, divisor in the name itself is there, it is a divisor. Suppose what is the HCF and 24 and 40? So factors are for 24 are 1, 2, I am writing directly, 3 8s, 4, then 6, then 8, then 12, then 24 is also multiple. Right, clear? So 1, 2, 3, 4, 6, 8, 24. These all are not multiple factors. So these all are the divisors for 24. 24 is divided by all these numbers. Similarly for 40, 1, 2, 4, 5, 8, 10, 20, 40. These all are the factors for 40. Just observe in these two, greatest, highest value which one? Observe in this, common, highest common is not 24, not 40, not 20. Just observe here, 8. Here also 8. So 8 is the GCD or HCF of 24 and 40. So like this we are going to find out any HCF or LCM, but it is not possible to write all factors and all multiples and find out the least common multiple and the highest common factor. That's why we will go for prime factorization method or Standard method is nothing but prime factorization or short division method. Suppose question is like this. What is the LCM of 8, 10 and 20? You need to find out the LCM of 8, 10 and 20. First you need to convert each number into prime factors. Prime factorization. So 2 4s, 2 2s, nothing but 8 equals to 2 cube. Similarly for 10, 2 5s. 10 is nothing but 2 power 1 into 5 power 1. 20, 2 10s, 2 5s. So 20 is nothing but 2 square into 5 power 1. Yes, these are the actually. Now I want to write a LCM for these three numbers is how much? Means LCM is nothing but you multiply all prime factors which are having the highest power. Just observe. Here 2 power 1 is there, here 2 square is there, here 2 cube is there. So which one is the, in 2 powers, which one is the maximum? Means 2 cube. That's why you need to multiply. Multiples nothing but larger value. Divisors are factors nothing but smaller values. So the multiples are always equal to that number or greater than that number. 8 multiples means starting from 8 onwards. 10 multiples means 10 onwards. 20 means 20 onwards. So multiples are always greater than that number. So divisors means equal to that number or less than that number. So that's why multiples means you need to always take maximum value. Yes. And 5 powers. 5 is not present in the 8, but because of that multiple means definitely it is common in all the 3 multiples. So that's why you need to multiply with what, right? In any one number is there also, you need to multiply with that, and which is also having highest factor, with that you need to multiply. 2 power 3 into 5 power 1, nothing but 8 into 5. So what is the LCM of 8, 10 and 20 means 40. This is one type. And one more is generally we use the short division method. It is the short division method. This is prime factorization method. Prime factorization method or standard method, we use it generally this. But from school days onwards, we learn this actually 8, 10, 20. LCM is how much means I divide 2 4s, 2 5s, 2 10s. Again 2 2s. So if 5 is not divisible, write 5 directly, and 2 5s. Then with 5, 2 is not divisible, that why 2 write as it is, and 5 1s, 5 1s. So after this LCM is how much means 2 into 2 into 5 into 2 into 1 into 1, nothing but 40. So this is the short division method. Generally we use that, but one condition is there. Short division always done with prime numbers only, but sometimes suppose if you are good in LCM and after practicing so many problems, then we go for that composite numbers, either 4, 8 also. In generally, we go for that prime numbers only, short division. So, for example, suppose if I take the 6, 1836, what is the LCM means? If 6 1s, 6 3s, 6 6, then 3 1s, 3 2s. So now 6 into 3 into 1 into 1 into 2. 36 is the LCM. But if I go for like this 6, 18, 37, first I divide with 18. 6 is written as it is, then 18 1s, 18 2s. Then 2 3s, 1s, 1s here. 8 into 2 into 3 into 1 into 1. So 108. Which one is the correct actually? This one or this one? Least common multiple. So it is the 36 is the least value. That's why it is always correct, but it is actually wrong. Why means instead of doing with the prime numbers, you go for that composite number 18. No? So 18 is a multiple of 6. That's why if you divide that by 6, no problem. But if you directly divide by 18, then you get a different answer. That 108 is a multiple of all these numbers, no doubt. But it is not the least common multiple. That's why, right, actually you go for with the prime numbers. Otherwise, sometimes you go for like this also, no problem. Right. These are the general methods. And we look one more question also. Suppose directly they gave 3 numbers like this. Suppose 2 power 5 into 3 power 4 into and 3 5 cube, then 2 cube into 3 power 5 into 7 square, then 3 cube into 2 power 6 into 11 power 2. So these are the three numbers A, B, C. What is the LCM for A and B and C? So already they gave in the prime factors itself. So prime numbers powers. So prime after completion of prime factorization, they gave numbers as like A, B, C. Then what in the LCM means? Just observe. So highest powers you need to 2 power 5, 2 power 3, 2 power 6. Observe 2 powers in all numbers. Which one is the highest? 2 power 6. That's why I write. Then into 3 powers. 3 power 3, 3 power 4, 3 power 5. Which one is the highest? 3 power 5. Then 5 is only present in the A. It is not present in B and C. But you need to take that 5 powers also in the LCM. So 5 cube is the LCM. Then into 7 square is also there, into 11 square is also there. So what is the LCM for the given above three numbers is 2 power 6 into 3 power 5 into 5 power 3 into 7 square into 11 square. This is the LCM for these numbers. So LCM is nothing but you need to multiply with all prime powers which are having the highest power. That's it. So if it is not necessary to present in the all numbers, so if in one number also you consider and multiply, that's it, sir. So 7 is only in B, 11 is only in C, 5 is only in A, but we write it in the LCM all the numbers also. Like suppose for the same three numbers, what is the HCF? For the same three numbers, what the highest common factor? Multiples means you always consider largest power, and it is not necessary to present in the all numbers. But HCF, highest common factor, that numbers are divided by some numbers means it must be present in the all numbers. It must be present in the all numbers. Right, just observe 2 power 5, 2 power 3, 2 power 6. 2 power is present in the A, B, C. But in all the three numbers, which one is present? Means 2 cube only. Means you consider the common power or least power of all the numbers. Right? And 3 power 3, 3 power 5, 3 power 4. 3 are there. So least value is how much? 3 power 3. 2 power 3 into 3 power 3. Then 5 is not present in the all number. That's why it is not in HCF. 7 is also not in all numbers. 11 power is also not present in the all number. That's why we are not considering that 5 power, 7 power, 11 powers in the HCF. So HCF is nothing but 2 cube into 3 cube. That's it for these three numbers. So HCF in definitely it must be common in the all numbers, and least power we will take and multiply in HCF. LCM means if it present in the single number also we will multiply with the largest power which is having in the observation of the given numbers slightly. Right? So this is the basics for LCM and HCF. And similarly, so LCM how we are going to find out after finding out prime factorizations, this is also, and short division method also. Okay, for HCF also we go with short division or prime factorization. Prime factorization already we looked at now. Suppose you need to find out HCF of 32 and 40. What is the HCF of 32 and 40 mean? I am writing directly here. 32 is equals to 2 power 5. 40 means 2 cube into 5 power 1 after dividing prime factorization. Just observe 2 power 5, 2 cube into 5. Now what is the HCF means? So 5 is not present in both numbers. That's why only 2 powers. That is also only 2 cube is present. That 8 is the HCF of 32 and 40. And HCF can be also done with short division method. But if and only if all numbers are divisible by divisor. Whatever the divisor you consider, that divisor need to divide all the given numbers. All the given numbers. That is important. Any number, right? Divisor, not need necessary prime number. Suppose these two are divisible by 8, 8 4s, 8 5s, and these two are divisible by 1. Until we get 1, we will consider like a short division. Then 8 into 1 equals 8. So like this we will done with short division for finding HCF also. This is another method. And sometimes normal division method. So 32 and 40 na. So first you divide largest number by smallest number. 32 once 32. What is the remainder? You get 8. After that, the first divisor you can divide that with remainder. Like this, you need to continue. So that 32 is divided by 8. 8 fourths 32. What is the remainder? 0. Whatever the last divisor, greatest common divisor or HCF with highest common factor, that is quotient. It is the factor. So HCF is how much means 8. This is the HCF. Right, like this, we are going to solve. Suppose one more question we look that. Right, suppose HCF of 42, 63 and 140. Find HCF of 42, 63, 140. So you go with the short division, that is also okay. All are 7 multiple, 7 6 42, 7 9 63, 7 20 6 9 and 20 are not divisible by same number. Why means 9 and 20 are co-primes. That co-primes concept is very very important. Co-primes are nothing but both are having the common factor as 1 only. Both are having common factor as 1. Right here 1. So HCF is how much means all numbers must be divisible by same number, then only we go for that short division method for finding the HCF. HCF is how much? 7 into 1? 7. Suppose if we go for normal division method, first you divide that largest number by smallest number. 42 once 42, then 21. Again you need to divide 21 twos 42, remainder is 0. After getting that, whatever the last quotient, last factor is there, with this, you need to divide another number. That 140 is there now. You need to divide that by 21. 21 6, 126. Remainder is 14. Again, you divide that 21 by 14. 14 once 14. Again, you get remainder. Again, you need to divide 14 by 7. 7 to 14. What is the remainder? 0. So, wherever you get the remainder 0, then that is the HCF. HCF is nothing but 7. So in any method we are getting same answers only, but for time saving purpose you go for that short division method or time factorization method or normal division method. Even for LCM also, prime factorization method, short division method, whatever you can. So whatever you feel easy, you go for that way and find that LCM and HCF as fast as possible for solving the problem. Like and so suppose in a question HCF of 0 and 14 is undefined, simple. Undefined. So HCF of 0 and 14 means undefined. Right. So 0, it is divisible by 1. 14 also divisible by 1. 2. 14, 7, these all are possible. So that's why HCF of 0 and any number is undefined. Next. HCF of distinct prime numbers is product. Suppose 2, 3. LCM is how much means 2 into 3. Suppose 5, 7, how much? 5 into 7. 3, 5, 7. 3 are the 5 prime numbers. 3 into 5, 15, 15 into 7, 105. So 3 are, this is LCM actually. LCM of distinct prime numbers is their product. So LCM of distinct prime numbers is their product. But HCF of distinct prime numbers. HCF of distinct prime numbers is always 1. That's it. We know already HCF of co-primes. Co-prime numbers is also 1. So clear, HCF of distinct prime numbers is always 1. LCM of distinct prime numbers means product. Not only distinct prime numbers, LCM of coprimes is also their product. Suppose 3 comma 20. 20 is not a prime number. 3 into 20, 60 is the LCM. So 5 comma, right, 12. 12 is not a prime. 5 12, so 60 is the LCM here. So this can be also helpful to solve some problems actually, right? HCF of 0 and any number is undefined. LCM of distinct prime numbers is equal to their product. LCM of coprimes is equals to their product. HCF of coprimes equals to 1. HCF of distinct prime numbers is equals to 1. And this can be helpful for finding that some, right, this can be helpful finding the statement type of problems, right? Statement type of, I mean, some questions they are giving like statements and which is the above or true, like that. The type of questions, those can be helpful. Suppose LCM and HCF for decimals. LCM and HCF for decimals. So whatever the decimals are there, suppose 0.21, 1.05 and 2.1. What is the LCM and what is the HCF? Suppose these are the three numbers given. So first you need to write all numbers having equal decimals. It is 0.21, okay, but it is 1.05, okay. You need to write zeros in the right side and equal to same decimal, so 2.10. So after that, so first you write all the decimals are in equal of the given number. Then after that, simply you remove that decimals and go for the LCM or HCF. First I write for LCM. These three numbers are divisible by 7. So 7 3s, 7 15s, 7 3s zeros. Again 3 1s, 3 5s, 3 10s, then 5 1s, 1s, 2s. So LCM is how much means 7 into 3 into 5 into 1 into 1 into 2. 5 2 is 10, 30, 2 10. But here all numbers is having two decimals, that's why I am placing that decimal last. The LCM is actually how much? 2.10. This is the LCM. Similarly, you go for that HCF 21, 105, 210. Same you go with the difference method is also there for finding the HCF. We will look that type of models at the problem solving section. So here these three numbers are again divisible by 7 3s, 7 15s, 7 30s. All three numbers are divisible by 7. That's why I am going for with HCF. These all three numbers also 3 1s, 3 5s, 3 10s. But here I place 1. Why means if 1 is there means definitely all three numbers are divisible by 1, or any prime number is there, 5 is prime number, definitely all are prime number multiples, then only it is possible. Otherwise all the numbers are divisible by 1 only. Right? Now HCF is how much? 7 into 3 into 1, nothing but 21. But you need to place one decimal. This is the actual HCF of given number. 0.21 is the highest common factor but the given three decimals. LCM is 2.10. How we are going to find out LCM or HCF for any decimals means first you write the numbers all are having the same decimals. Whatever the decimal numbers are given there, you need to equate decimals in those numbers. After that, remove decimals and find the normal LCM and place that decimal. If two decimals means 2, 3 means 3, single decimal means single. Similarly for HCF also, remove first equate all numbers having same decimals, then find HCF, then and finally you place again that decimal to that resultant. That is the procedure actually. So how we are going to find out the LCM and HCF for decimals. Similarly, how we are going to find LCM and HCM for fractions. LCM and HCF for fractions, suppose. So suppose 1 by 2, 3 by 5, 9 by 10. These are the three fractions. First, you need to find out LCM and HCF again. For fractions, LCM means simply LCM of numerators. By for denominators, you need to find out HCF of denominators. Suppose you need to find out for HCF for the given fractions means you need to find HCF of numerators divided by LCM of denominators. Like that, you are going to find out. So, LCM of numerators means LCM of 1, 3, 9 divided by HCF of 2, 5, 10. That's it. So LCM of 1, 3, 9 is how much? Means 9. 9 is a multiple of 1 and 3. That's why that is the largest number. That is the 9. And HCF of 2, 5, 10. 2 and 5 prime numbers. If prime numbers means HCF is always 1. So LCM for this given fractions is how much? Means 9. And HCF for given fractions, suppose HCF of 1, 3, 9 divided by LCM of denominators 2, 5, 10. That's it. HCF of 139, that 1 is there, so 3 is prime number. 1 and any other number is there means always their HCF is 1 only, divided by LCM of 2, 5, 10 is nothing but 10. So 10 is multiple of both 2 and 5, that's why 10. Or otherwise you go for that short division and write also, no problem. So how we are going to find out LCM for fractions means for numerators LCM and for denominators you go over HCF. Similarly for HCF of numerators by LCM of denominator, then you will get that resultant HCF for given fractions. Like this you are going to suppose in the numbers 4, 7 by 8 like this means you always consider it is nothing but 4 by 1, 7 by 1. Sometimes they are given direct natural numbers or whole numbers, integers like that means. So 4 is nothing but 4 by 1. Like that you convert and 7 by 8. Here LCM means LCM of 4 and 7 divided by HCF of 1, 8. Like that you need to solve. Right? So why means so many times students forgot that in the denominator one, instead of that 4, 7 means no doubt LCM they will find out, but for HCF means only they write 8 only. That's why sometimes 2 or 3 fractions is given and one is a direct integer. Then you consider the denominator as 1 and find a HCF and LCM for the fractions. This is the other case. These are the basics for LCM and HCF. So, right, again at the time of problem, you will get a very clear idea what type of problems are they are asking and we will go further. Now, next, suppose, here is, we will solve one problem, very basic problem actually. Suppose, first number is given as 3240. Second number is given as 3600 and third number we need to find out that third number. In the question HCF is given as 36 and LCM is given as 2 power 4 into 3 power 5 into 5 square into 7 square. Then you need to find out the third number. This is the actually question. So first one of the number is 3240, another number is 3600. LCM of three numbers is 2 power 4 into 3 power 5 into 5 square into 7 square. HCF equals to 36. Then find the third number. Right. So how we are going to solve this question? Why means so once we solve this question means definitely we have that differentiate of how we are taken that LCM and HCF from prime factorization only for that. For clear understanding purpose, this question is important. 3240, convert prime factorizations. So 21620, then again 2810, then 2405, and then it is 3135, then again 3 4s 5s, then 3 15s, then 3 5s. Similarly for 3600, so 2 1800s, then 2 900s, 2 450s, 2 225, 375, 325, 55. So I am writing here 3240 equals to how much? 2 power 3 into 3 power 4. 2 power 3 into 3 power 4 into 5 power 1. This is the clear. 3600 is nothing but 2 power 4 into 3 square into 5 square. That's it. Now, third number we don't know exactly. We need to find out this third number, but HCF 36 means 4 nines, so 2 square into 3 square. LCM is how much given? 2 power 4 into 3 power 5 into 5 square into 7 square. Now observe and find out the third number. HCF means it must be common in the all numbers. LCM means largest power present in the all numbers. After observing. So HCF is 2 square. Just observe here. In this question, right, in first number 2 cube is there. In the second number 2 power 4. Suppose in the third number 2 cube means definitely in the HCF also 2 cube. 2 power 4 means again 2 cube. Right? But in the HCF what they are given as 2 square means in 2 powers. In the third number it must and should 2 power 2 only. Other than that it is not possible. Suppose if I write only 2 means in HCF also 2. 2 cube means 2 cube. So 2 power 4 means also 2 cube, whatever the power you write. Hence 2 cube is common in the all three numbers, 2 cube. But if third number is having 2 power 2, then observing by comparing all this, all the 2 powers are common in the three numbers. So that which where is the least, that is reflect in the HCF. So 2 square is the that third number is having. Then go for that HCF. 3 square, already in the second number 3 square, in the first number 3 power 4 is there. But observe LCM here, 2 power 4 into 3 power 5. 2 power 4 is already there in the 3600. But 3 power 5 is not present in these two numbers. 100% this 3 power 5 present in the third number. Then only we get 3 power 5 in LCM. Otherwise we are not having a 3 power in that third number, right? So 3 power 5 is LCM means definitely in the among three numbers, one number is having 3 power 5. Where it is means in the first two numbers it is not there, means definitely it is in the third number. It fulfills that 3 square condition also HCF. Why means 3 square is the least common factor among the three numbers. And 5 powers in the two numbers are the 5 power 1, 5 square. In the LCM 5 square is there, but in the HCF 5 powers are not there, means third number is not containing any 5 powers. Why means if 5 powers are there, it reflect in the HCF also. That's why in HCF 5 powers are not there, means third number is not having 5 powers. But in the LCM 7 square is there. 7 is not present in the first two numbers, means definitely that 7 square is present in the third number. That's why it reflects in the LCM. So like this we need to analyze and solve LCM HCM problems. Why we solve this one means once we understand this problem, then very easy to solve other problems, and very easy to understand the core concept of LCM and HCF. So LCM is always by writing the large powers multiples which are present in any number also, not need necessary to present in the all numbers. But HCF nothing but it is must be present in the all numbers which is having the common power or least power. Those are the reflect in HCF. That is very, very important. These are some very basic concepts for LCM and HCF. And some concepts are there. Suppose if I take that 4, 6 are the numbers, what is the LCM? Very simple. 4 and 6 LCM is 12. 2 2s, 2 3s, 2 into 2 into 3. What is the HCF here? So 2 numbers are divisible by 2. Just observe. 4 into 6 equals to 24. Here 12 into 2 equals to 24. So here product of two numbers, any two given numbers, product of two given numbers is always equals to product of their LCM and HCF. Product of any two given numbers is equals to always product of their LCM and HCF. This one is one thing. And I take this 4:6. What is the ratio? 2 2s, 2 3s. The ratio is given as 2:3. And so suppose if ratio of two numbers is given as A:B and HCF equals to some K. Suppose just observe HCF equals to, then what are the numbers means? If you multiply 2, the ratio terms, 2 into 2, 4, 3 into 2, 6. So one number equals to A into K. Other number equals to B into K. And in this case, LCM equals to A into B into K. 2 into 3, 6 into 2, 12 you get. Right. Only for understanding purpose, I took that 4 and 6. So whatever the numbers you take and check, always these two statements are correct. Product of any two given numbers is equals to the product of their LCM and HCF. And if ratio of any two numbers is given as A:B and HCF is given as K, then one number is A into K, other number is B into K. LCM is nothing but A into B into K. So we use this concept and solve some problems, and we apply this conditions for solving the problems. So this is also an important concept. And right. Okay. Now types of problems. Actually, here I give that outlook. Then at the time of problem solving, you have clear idea. But before that, we discuss here some basics. Actually, right. So types of questions or types of problems. First, suppose in the question, what is the least number which is divisible by A comma B comma C or A B C D E, whatever it is. Suppose question is find the least number which is divisible by A B C all, which is divisible by completely by A B C, right, or exactly divisible by A B C. In this case, just you need to find out LCM of A B C. That's enough. LCM of ABC means least common multiple. That is the number which is exactly or completely divisible by A, B, C and gives remainder 0. That's it. Similarly, questions are framed like this. Least number which is divisible by A comma B comma C and leaves always remainder K. Leaves always remainder K. Suppose. Right? So in this case, leaves always remainder K. So what is the number we get means, suppose if we find LCM of A comma B comma C, means that number which is exactly divisible by ABC, but extra remainder means excess value. remainder means excess value. So that's why we need to that K for that LCM of given numbers, whatever ABC, ABC, D, ABC, DE, whatever the numbers, you need to add that remainder to the LCM, then you will get that required number, what they are. Find the least number which is divisible by ABC and leaves K remainder always. So in this case, just you need to add that remainder to that LCM of given numbers. That's enough. Suppose sometimes they are framing questions like this. Least number which is divisible by ABC and leaves remainders P comma Q comma R respectively. So find the least number which is divisible by ABC and leaves three different remainders. In this case, suppose if you consider this difference A minus P, B minus Q and C minus R, definitely this difference of the divisor and the remainder value must be equal to some constant. Maximum 99.9% questions are having the same difference. Suppose in some questions the difference is not possible, means simply you go through options and eliminate options based on the divisors given in the question. So in this type of questions you need, so definitely that difference between the divisor and their remainder. Divisor and remainder is constant. In this case, you find LCM of given number. Then you need to subtract that whatever the common difference. Whatever the K value, nothing but a common difference, then you will get that required number. So these are the three main ones, and sometimes least number which when increased by, suppose K increased by 10, 5, 20, whatever increased by K, then that is exactly divisible by A comma B comma C. In this case, suppose so 10 is there, 10 is increased by which number, then it is exactly divisible by A comma B comma C. Write 2 comma 3 comma 5 like that. So questions framed like that. So for that type of questions, how we are going to mean? So here LCM of ABC is always divisible by ABC, no doubt. But here least number which when increased means that is the actual number. ABC means LCM. But after increasing, then we get that LCM. Here least number which when, suppose if 20 is divisible, 20 is LCM means something we add to that given number, then you will get 20. Nothing but this K goes that side means 20 is the LCM means 20 minus K, then we get that whatever they are asking that required number, that is the number. So that number is increased by K, then you will get LCM. Means how we are going to solve means simply find LCM and subtract whatever the constant given in the so minus K value. Suppose which when decreased or diminished or reduced means you need to add that K to LCM. Add to that LCM. So these are the different models. So these two are the very rare actually. Again, it is decreased means LCM of ABC plus K. Why means LCM is actually less than that number. In this case, LCM is more than that, whatever they are asking that number. Right? Clear? These are the different cases LCM problems on numbers related actually, not application oriented. Those all are numbers related. Similarly, for so HCF, suppose greatest number that divides A comma B comma C. Question is framing like greatest number that divides A comma B comma C. Then we go for the HCF of A comma B comma C. That's enough. That is the answer. Greatest number that divides A comma B comma C. And suppose greatest number that divides A comma B comma C and leaves remainder K always. This one is important. That basic is not important. Remainder K always means suppose if K is remainder means if first number is that number is divided by A, we get K. B also we get K. C also we get K as remainder means if you subtract that number from A onwards. So for this type of question, simply if you subtract that K from each and any number, HCF of A minus K and B minus K and C minus K, this is the resultant number, whatever. So why means always if you divide that A by that number, then you get K, B by that number K, C by that number K. Always you get K as remainder means simply subtract that remainder, and what is the remainder means 0 you get. So simply whatever the remainder is there from the number, so the resultant values HCF is nothing but they are asking. So greatest number that divides ABC and leaves remainder K. Suppose here one more type, there is a chance of greatest number that divides ABC and leaves remainders P comma Q comma or A, whatever it is respectively. So 3 numbers means 3, 4 numbers means 4 remainders, like that. Here same remainder means you subtract K from all number. Here different remainders means you subtract that whatever the remainders are there, that respective remainders, A minus P, then B minus Q and C minus R. HCF of this is the whatever they are asking, find it. So these are some different, right? Again, learning the concept is different and application of the concept to questions is different. So while solving the problems, this can be helpful, and once after solving, then you have clear idea what type of questions we are going to solve through LCM and HCF. Simple, LCM is always greater than the given numbers, right? Suppose in the question numbers are there, options are definitely greater than the given numbers means that is the LCM related, and HCF means definitely it is less than that remaining numbers are equal to smallest number, like that we are going to find out. And these are numbers related questions, but application oriented questions are there. Application oriented means suppose LCM application oriented type of question means suppose a person, right, person A went to swimming every 3 days. Person B went swimming for every 4 days. Person C went swimming for every 5 days. Suppose all are met in today, then again after how many days they are going to meet the swimming pool. So like that type of questions means. So here nothing but 3, 4, 5 LCM is 60. After 60 days they meet again. So all come together, yes, and meet next time. Some members are there, some different time periods are there, and after how much time again they meet, and again traffic lights related questions. So at a traffic signals, red light is blink after every 5 seconds, then green is for 10 seconds, then yellow is for 15 seconds. So all are light at all are simultaneously light at 8 a.m. Then after how much time, or after how much time, at what time they will again all light together or simultaneously lighting. So those type of traffic lights. Suppose in a circle also, in a circle one person completed in 20 seconds, another person completed in the 30 seconds. After how much time they both met, and so many different types of questions framed on this type. Not only this, and bells ringing in a temple, that different spans are given. So bells ringing in a temple. So three bells are ringing in a temple at 10 seconds, 20 seconds and 30 seconds intervals of time. Again at what time? or after how much time they three bells rang at a time, like that. So many questions are framed on this concept. LCM later means all come together, or next time meeting based on persons in a circle how much time. So different persons are running in a circle with a different time period. So different time intervals are given after how much. These type of questions are LCM based generally, and HCF based some questions are there. Suppose 1,000 chocolates are there, right? 1,500 pens are there. Those are distributed equally among the students. How many students are the maximum number of how many students are there possible, and the least number of students. So like that are question. Number of persons or number of students or number of fruits, baskets, whatever. So they are asking, but maximum number of students are how many, maximum number of persons are how many. So those type of questions actually related to HCF concepts. Again, not only this, so they are asking about maximum size of bottle. Here, this one is important. Suppose three jars, different jars are there. So in that different quantities of oil, water, whatever is there, liquids are there. So what is the maximum size of a bottle or vessel is required to measure that quantity of that liquid exactly in integers? So you need to find out the size of that bottle. Size of that bottle means you go for that HCF. Maximum number of persons are how many, or maximum size of the bottle. And sometimes they are asking two different lengths are given. What is the maximum possible length to measure? Those type of questions are framed based on that HCF concept. And some questions are there here, maximum size of bottle here. Right. Number of bottles required. Find the least number of bottles required. Least number of bottles. Least means not LCM. Find the least. Suppose some liquids are there. Right. We need to fill that liquid with a different size bottle. So least number of bottles required are how many means you must take the size of the bottle is maximum. If bottle size is maximum, then number of bottles we get the least. If bottle size is minimum, the number of bottles in the resultant are more. So least number of bottles you need to find out means you must take the maximum size of bottle. First you need to maximum size of bottle by using HCF concept. After that you need to find out how many number of bottles are required to fill that whatever the liquids are given. So these are the some questions actually. Here I am giving only outlook of LCM and HCM. At the time of problem solving, so you have clear idea how we are going to solve this LCM and HCF. In the next class, we will solve this LCM and HCF practice questions. After that, we will look into the CSAT PYQs also, right? Thank you.